Today we're going to be talking about internal combustion engines. This is the generic model of what's used in most cars today.
Most combustion engines have 4 strokes to every 2 revolutions of the engine. The first one is called the intake stroke. The piston goes down, creating the maximum volume inside the combustion chamber, as shown in the diagram on the left. This creates a vacuum inside the chamber which sucks in an air-fuel mixture from the intake valve.
The next step is called the compression stroke, where both valves are closed and the piston shoots upward, decreasing the volume in the fuel chamber and increasing the pressure, temperature, and density of the fuel mixture.
The next stroke is called the power stroke. In this step, the spark plug fires an electric charge which ignites the air-gas mixture, causing an explosive expansion of these gases. This is the step in which the force for all 4 steps is created.
The fourth and final stroke is called the exhaust stroke, in which the exhaust valve opens, the piston shoots upward, pushing out all the gases out of the exhaust valve, and then the piston is in the minimum volume position, allowing for the whole process to start over again.
The only stroke in this 4-stroke cycle in which energy is actually generated is called the power phase. This energy is the driving force behind the other 3 phases of the 4-stroke cycle, and it also is the driving force which turns the crankshaft, which lets your car move. It should also be noted that all cars have more than one piston, and at any point while you're driving, all the pistons are at a different point in their 4-stroke cycle. If they're all at the same point in the stroke cycle, then you would have a massive lurch forward every time the pistons went into the power stroke. Let's talk about the combustion reaction that happens in the power phase. Okay, so we have our hydrocarbon and oxygen mix in the combustion chamber. Then the spark plug gives off a spark which ignites the mix. Oxygen is going to take a hydrogen atom from the hydrocarbon. The bond between the hydrocarbon and the hydrogen is broken. The hydrogen will get 1 electron, and so will the hydrocarbon. This results in the formation of a radical. Many different radicals can be formed this way, and all of their decomposition reactions and resulting reactions are very exothermic, and this is how we generate all that energy.
At the end of this reaction, the resulting products are water and carbon dioxide.
Internal combustion engines can use a variety of fuels. I'm going to tell you about diesel and unleaded, the most common. The difference between these 2 fuels is that diesel fuel is a longer hydrocarbon chain, usually around 10 carbon atoms long. Gasoline is usually around 8 and less carbons. These different lengths of hydrocarbons will give diesel and gasoline fuels different chemical properties. Diesel, which has longer hydrocarbon chains, will have a higher boiling point, which will make it harder to combust. Gasoline has a smaller hydrocarbon chain, so it will have a much lower boiling point and will be much easier to combust. This is why gasoline and diesel engines are so different. Diesel fuel must be pressurized to a much higher pressure before it can be combusted to generate heat and force. Diesel and gasoline are extracted from crude oil by distillation. Distillation is a commonly used technique in organic chemistry that separates compounds on their boiling points.